Section 5.2, Properties of Parabolas. The graph of a quadratic function in standard form. The graph of a quadratic function, we already know the standard form is f of x equals ax squared plus bx plus c. When you graph that quadratic function, what you get is a parabola, and that is when a does not equal 0. If a equals 0, that term, or the quadratic term, would drop out, making this a linear function. The parabola is a U-shaped figure that can point up or point down. We have constrictions with the parabola. When a is greater than 0, the parabola opens up, as demonstrated in this diagram. When a is less than 0, the parabola opens down. Therefore, if the first term, the quadratic term, is positive, it points up. If the quadratic term is negative, it points down. The axis of symmetry is the line that is denoted by negative b over 2a. The axis of symmetry, as we already know, is a line that is a vertical through the vertex and maps every point the same distance from the left of the parabola to the right of the parabola from that line. So if this is 3 units to the left on the axis of symmetry, then this has to be 3 units to the right. In other words, if I folded a piece of paper, the parabola's left side and right side would match up exactly. The x-coordinate of the vertex is a negative b over 2a. The y-coordinate is the value of that function when x equals a negative b over 2a, or y equals f of a negative b over 2a. The y-intercept is 0. The next few slides will separate that previous slide into different sections so we can get a better look at what's really occurring. Here, if I have a quadratic function, my quadratic term has a coefficient of a when a is positive or greater than 0, then my parabola is going to open up. If a is greater than 0, then the parabola opens upward. This quadratic function, again, a is the coefficient of the quadratic term. If a is less than 0 or negative, then my parabola will open down. The axis of symmetry is the line that divides a figure into 2 parts that are mirror images. How do I get the axis of symmetry? The axis of symmetry is given by a negative b over 2a. Remember, a is the coefficient of my quadratic term. B is the coefficient of my linear term. Recall, since the equation only has the variable x, it will be a vertical line. The vertex is the point where the function for the parabola reaches the maximum or minimum value. The parabola intersects its axis of symmetry at the vertex. And if we go back to the diagram of a parabola, we have one opening up. Therefore, the vertex is a minimum. Here, when it opens down, the vertex is the maximum value in that parabola. Once I determine the axis of symmetry, this generates my vertical line. X equals this value. This also becomes the x-coordinate for my vertex. Now I have to find the y-coordinate. To find the y-coordinate, I need to substitute the x-coordinate into the given quadratic function. That represents the notation on the left. So I plug in my x value into the quadratic function. C is going to be some number that is already given to me. And therefore, remember f of x is y. When I solve my problem after substitution, that gives me my y-coordinate. Here's the procedure that we want to use to graph a quadratic function. First, we want to find and graph the axis of symmetry. And we know how to do that from the previous slides. 2, we want to find and graph the vertex. 3, we want to find and graph the y-intercept and its reflection. And last, we want to evaluate another x value, that would be our choice, and graph the ordered pair that we arrive at after we substitute into the quadratic function, and then we want to graph its reflection. On this slide, we're asked to graph each function. Our function is y equals x squared plus 2x minus 3. Our quadratic term has a coefficient of a. Our a is a positive 1. Our linear term has a coefficient that is b. B is represented with a 2, and the minus 3 is our c. The first thing in our procedure to graph a quadratic function is we need to find the axis of symmetry. So our axis of symmetry is given by this equation. X equals a negative b here is 2, over 2 times a, which is 1. When I simplify, that's going to give me a negative 1. So my equation for the axis of symmetry is x equals a negative 1. I know that that is a vertical line at negative 1. So I'll just graph that as a dotted line through x equals a negative 1. That line represents my axis of symmetry. I need to find my vertex. My vertex is a negative b over 2a, comma, f of a negative b over 2a. Therefore, I'm already given this part. That's my x-coordinate. My x-coordinate is a negative 1. I know that because it has to fall on my axis of symmetry. What I need to do now is substitute that x value into my quadratic function that is given to me. So when I do that, y equals a negative 1 squared plus 2 times a negative 1 minus 3. Therefore, y, when I simplify, I'm going to get 1 minus 2 minus 3. That gives me my y-coordinate equal to a negative 4. Therefore, my ordered pair for my vertex is going to equal a negative 1, negative 4. Now I just graph my vertex, a negative 1, 1, 2, 3, 4. I also know by looking at my given function that a is a positive value. Therefore, I know that my quadratic function, or the parabola that I graph from that quadratic function, is going to open upwards. Now I need to graph my y-intercept. And my y-intercept is 0, comma, c. And my c is a negative 3. That's going to give me 0, 1, 2, 3. I map the mirror image over the axis of symmetry. It's 1 unit to the right on my axis of symmetry, so I'm going to count 1 unit to the left for its mirror or reflected point. Now I choose one more point, or x value, to finish the parabola. I'm going to choose a positive 1. So when x equals a positive 1, I'm going to get 1 squared is 1, plus 2 times 1 is 2. 2 plus 1 is going to give me 3. 3 minus 3 is 0. So I graph that other ordered pair, 1, 0, and I graph its reflected point on the other side of the axis of symmetry. It's 2 units to the right, so its reflection will be 2 units to the left. Then I sketch my parabola. And here is a graph that represents this quadratic function. Again, we want to graph the quadratic function. Here we're given f of x equals a negative x squared minus 2x. This is my quadratic term. It has a coefficient of a. My a is a negative 1. My linear term has b for its coefficient. Its coefficient is a negative 2. The c is not present in the equation. Therefore, I know that my c is 0. So I need to find my axis of symmetry first, represented by this formula. So x is equal to a negative, b is a negative 2, over 2 times a, which is a negative 1. A negative 2 divided by a negative 2 is a positive 1, but that makes it negative. My axis of symmetry has an equation of x equals a negative 1. I know that that is a vertical line through the x-coordinate of a negative 1. And I'll generate a dotted line to show that on my graph. That's my axis of symmetry. Now I need to find the vertex. And I know my vertex has the x-coordinate given from my axis of symmetry, so that's a negative 1. All I need to do is substitute that value into our quadratic equation given to us, and I'll generate my y-coordinate for the vertex. A negative 1 squared is 1, but that makes it a negative 1. A negative 1 times a negative 2 is a positive 2. 2 minus 1 is 1. So the vertex has an ordered pair of a negative 1, 1. I also know from looking at the given problem that my A is negative. Therefore, my parabola will open down. That tells me that this vertex is a maximum value in my problem. Now I need to find the y-intercept. And I know my y-intercept is 0, comma, c. And my c here is 0 since it's not present. So I graph my y-intercept, and I map its reflection over the axis of symmetry. It's 1 unit to the right, so I'll map it 1 unit to the left. Then I select another ordered pair, and I'm going to choose x to be a positive 1. And when I substitute 1 into my original problem, I get 1 squared, which is 1. That makes it a negative 1. And 1 times a negative 2 is a negative 2. A negative 1 minus a negative 2 is a negative 3. Then I graph that ordered pair, 1, 1, 2, 3. Then I graph its reflection over the axis of symmetry. It's 2 units to the right of the axis of symmetry, so I'll map it 2 units to the left. Then I sketch my parabola. And my parabola did open down because of A being a negative 1. The vertex is a maximum since it's opening downward. And this graph is the representation of this quadratic function. Again, they want us to graph a quadratic function. They also want us to label the vertex, axis of symmetry, and determine whether this is a maximum or minimum value for the vertex. Our function, f of x equals x squared minus 9. Our quadratic term has a coefficient of a. It is a positive 1. My linear term is not present. Therefore, my b is 0. And my c is a negative 9. Let's start with the axis of symmetry. It is given by this equation. So x equals a negative, b is 0 over 2 times a, which is 1. And 0 divided by anything is 0. So my axis of symmetry is a vertical line at x equals 0. I'll graph that with a dotted line. And I know that my a is a positive 1, so my parabola will open upwards. And that tells me I will have a minimum value for my vertex. My vertex has an x-coordinate represented here of 0. And now I just generate the y-coordinate by substituting 0 into my given quadratic function. Substituting in 0, I get 0 minus 9. I get a negative 9. When I graph that, I'm going to get 0, negative 9. And that is where my minimum is going to be. So that's already given to me. And now I need to generate the y-intercept. And that y-intercept is going to be 0, comma, what c is. And c is a negative 9. So my y-intercept is the vertex. Now, since it is the vertex, I need to generate 2 x-coordinates other than the one given to me. So in this problem, I need to choose 2 x values since the vertex is my intercept. So I'm going to choose 1. When I substitute in 1, 1 squared is 1. 1 minus 9 is a negative 8. And I'll choose 2. 2 squared is 4. 4 minus 9 is a negative 5. I can now graph each of these ordered pairs and their reflection over the axis of symmetry. So 1, negative 8. And I'll map that over the axis of symmetry. And 2, negative 5. And then I'll map that over the axis of symmetry. Then I can sketch my parabola. And then check to make sure I've answered all the problems. Label the vertex. I have that labeled. The axis of symmetry is here, and this is a minimum value. And this graph represents the quadratic function, x squared minus 9. Again, we're asked to graph a function, label the vertex, axis of symmetry, and determine whether the vertex is a maximum or a minimum. Here, our quadratic function is y equals a negative 3x squared plus 4x plus 1. Our quadratic term is a coefficient of a, and that is a negative 3. The linear term, coefficient of b, which is 4, and our c is a 1. We need the axis of symmetry, represented by this equation. Therefore, x is equal to a negative b, which is 4, over 2, a, which is a negative 3. That gives me 4 over a negative 6, but a negative and a negative is a positive, and 4 over 6, when you simplify, is going to be 2/3. So the equation for my axis of symmetry is x equals 2/3. That's a vertical line at 2/3. And I'll put a dotted line at x equals 2/3. This represents our axis of symmetry. Now I need to find my vertex. And before I go any further, I know that I'm going to have an a that is negative. Therefore, I'm going to have a parabola that opens down. And therefore, this is going to be a maximum in my quadratic equation. My vertex has an x-coordinate represented here, which is 2/3. Then I just substitute into the original problem and generate my y-coordinate. Here I've substituted 2/3 into my original quadratic equation, and when I simplify it, I got 21 over 9, and I simplify again, and I get 7/3. Therefore, my vertex is at 2/3. It's on the axis of symmetry, and 7/3, which is 2 1/3. 1, 2, and approximately 1/3. Now I need to find my y-intercept. We recall that that is 0, comma, c, which is 1, 0, 1. I graph that, and it's mapping over the axis of symmetry. That is 2/3 away, so I need to go 2/3 away to the right. So this is 1/3, and then approximately another 1/3, which is 2/3. And now I need to find an x value. That is my choice. I'm going to choose a negative 1 and then substitute into my original equation. A negative 1 squared is 1 times a negative 3 is a negative 3 plus 4 times a negative 1 is a negative 4 gives me a negative 7 plus 1 is a negative 6. And when I graph that, a negative 1, negative 6, that ordered pair is 1 2/3 units away from the axis of symmetry. So I need to go 1 2/3 units away to the right. From here to here is 1/3. There's my 1, and I need another 1/3 approximately right here. And that would be 1 2/3 units away. Then I sketch my parabola. Then I make sure I answered all the questions. I labeled the vertex. It is at this ordered pair, represented on my graph. The axis of symmetry is here, and my vertex is a maximum. On this problem, we're given the total profit P made by an engineering firm is given by the equation P, which equals x squared minus 25 plus 5,000, a quadratic equation with a quadratic term having a is 1. My linear term b is a negative 25. And C is 5,000. We want to graph the equation, find the minimum profit made by the company. Here, we have the axis of symmetry as we have in the past. X equals a negative b over 2a. This is a negative 25 over 2 times 1, which gives me a double negative for a positive 12.5. That is equation for the axis of symmetry. That's my vertical line. And I counted by 5, 10, 15, so this is a 12.5. Vertically, I'm going up by 1,000, so 1,000, 2,000, 3,000, 4,000, 5,000. My vertex is the x-coordinate of 12.5. When I substitute into my original equation, I get 4,843.75. I graph my vertex. My y-intercept is 0, c, which is 5,000. I graph the y-intercept and its reflection point. I select another x value. I select a -1. When I substitute into the original equation, I get 5,026. And when I graph that and its reflection point, then I can sketch the parabola. I know from my equation that my quadratic term has an a that is positive, therefore it is opening upwards. That will determine that my vertex is a minimum. And they wanted a minimum profit in my problem, therefore that is at the vertex 12.5, 4,843.75. My last example. Here, for each function, the vertex of the function's graph is given. We want to find c. Here we have a quadratic equation, y equals a negative x squared plus 2x plus c. I'm given what is the vertex of the function. This could be the vertex or any other ordered pair on my quadratic equation or my graph. And if that's given to me, I know that I have an x-coordinate or an x value and a y-coordinate or a y value. Therefore, all I need to do is substitute these x values and y values into my quadratic equation and solve for c. And that's what they're asking for. So let's just do that. Let's substitute in 6 for y, negative, and then for x, I'm going to substitute in 1. Now, all I need to do is simplify this equation and solve for c. That gives me 6 equals 1 squared is 1, but that makes it a -1, plus 2 plus c. 6 equals 1 plus c. Subtracting on both sides, I get c equal to 5. So, the quadratic function is y equals a negative x squared plus 2x plus 5.